Good morning, guys. Today we're going to talk about angles, specifically angle pair relationships. All right, so we're going to go over some relationships, and then we're going to look at how we can use those to solve problems, a little bit of the algebra. But first we need to be able to name them, define them, all that kind of good stuff. So the first one we're going to start with is vertical angles, all right? Vertical angles are two angles across from each other on intersecting lines. They are always congruent. So for example, if I have angle 1, 2, 3, and 4 here, angle 1 and 2 are vertical angles. I'm sorry, 1 and 3 are vertical angles. So angle 1 is congruent to angle 3. All right, that congruency piece is key. We're going to keep using that for forever, quite honestly. Linear pairs is the next one. I'm just going to kind of go clockwise. All right, linear pairs. So actually, let's do adjacent first. Adjacent, as I changed my mind. Adjacent angles are angles that are next to each other. So, for example, angle 1 and 2 are adjacent. We could also say 2 and 3 are adjacent, 3 and 4 are adjacent, 4 and 1 are adjacent. 2 and 4 are not adjacent, right? Those are vertical angles. Same thing for 1 and 3, but 1 and 2 are adjacent, 1 and 4 are adjacent. Now let's look at linear pairs. These are two angles that are adjacent and supplementary. All right, they form a straight line. So angle 1 and angle 4 are a linear pair. They are a linear pair. When we look at supplementary, this is one that any two angles whose sum is 180. So angle 6 plus angle 5 is equal to 180. Or we have angle 3 plus angle 4 is equal to 180. All right, so if you have two right angles, those do add to make 180. I know it's a little bit of a duh thing. Need to say it anyways. Complementary angles are two angles whose sum is 90 degrees. So here we have angle 1 plus angle 2, and they are complementary. They add to make 90 degrees. So we have our angle relationships. Vertical angles, adjacent angles, linear pairs, supplementary angles, and complementary angles. Now we're going to look at actually assigning these to angles. So we're going to take a look at 1, 3, and 5 here. All right, our first one, we have angles 1 and 2. We are just going to look at angles 1 and 2, and we're going to describe everything we can about them. Well, are they adjacent? Are they next to each other? No. Are they vertical? Yes, they are vertical. You can kind of tell because they both form V's. 2 is an upside down V, but that's a good way of relating them is that they form those V's kind of. Complementary, do they add to make 90 degrees? I don't know. Nowhere on here is 90 degrees marked, so I can't tell if they're complementary. I can't tell if they're supplementary either because 90 degrees is a marked anywhere on here. There's no measurements given, so I just don't know. And then linear pairs is the last one. I don't know if they form a line. They're not next to each other, which is one of the things that linear pairs have to be, so I can say that they are not linear pairs. So number 3 here, we have 1 and 2 again. Are they adjacent? Are they next to each other? Yes, they are next to each other. Are they vertical? No. If they are adjacent, they cannot be vertical. Are they complementary? Neither of them is marked as 90 degrees, so I definitely can't tell that they're complementary. Are they supplementary? Let's come back to that. Are they a linear pair? Do they form a line? Yes. They are supplementary, they are a linear pair, they are adjacent. All three of those things. So we take a look at number 5 down here. We have angle 1 marked and angle 2 marked. What's interesting about angle 1 is we have this little line here and here, right, with those tick marks. That means that angle 1 and this unknown angle here are congruent. They're congruent angles. And we know that this right here is 90 degrees. So that means that angle 1 plus our unknown angle are complementary. They make 90 degrees. Well, wait a second. Angle 1 and angle 2, are they adjacent? No. Are they vertical? Yes. Wait a second. Vertical angles. That means they're congruent. So if angle 1 is half of 90 degrees, that means so is angle 2. So if I add them together, they make 90 degrees. It's complementary. So do you see how important these diagrams are? Knowing our tick marks, our swooshy marks, in this case for angles, all of that is really critical to being able to decipher this diagram and what it means, why we care. All right, let's take a look at the second page. We're going to define the angle pair relationship, and then we're going to use that to find our unknowns. So when we take a look here, we've got 112 and some unknown x. What is their relationship? They are vertical angles. Well, here's the great thing. Vertical angles are congruent. So that means x is equal to 112. Done. Wasn't that nice? Our next one right here, we've got x and 68. But there's a very special mark here in the corner. These angles have a relationship. They are complementary. They add to make 90 degrees. So that means x plus 68 degrees equals 90 because of this little mark here in the corner. So I can subtract 68 degrees on both sides, and we are left with x is equal to 22. Awesome. Hopefully we're feeling pretty good about those. Let's take a look at this one next. All right, let's take a look at this one next. So this one, we have two angles. They are next to each other, but that's not how I'm going to define them. I'm not going to define them as adjacent. I'm going to define them as a linear pair. And here's why. Linear pairs are adjacent and they add to make 180. They're supplementary. So that means 124 plus x is equal to 180. So I can subtract 124 from both sides, and we get x is equal to 56. So that is our answer. All right, let's do something that's a little weirder. Let's do this one down here. And this will be our last example. So we are trying to find x, y, and z. All right, you can pick any of them to start with. I like to go in, let's go with a reverse alphabetical order. All right, let's start with z. So for z, we know that z and 72 are complementary. So z plus 72 is equal to 90. All right, we know that. So that means that if we subtract 72 on both sides, we get z is equal to 18 degrees. All right, we know that one. For the next one, let's do x. Oh, I said reverse alphabetical, didn't I? So that means we should do y next. All right, let's do y. So y actually has relationships with lots of other things on here, right? It is adjacent to this 90-degree angle. Doesn't really help us. It's adjacent to x, and they form a linear pair, but we don't know x, so that doesn't really help us either. But there's one key relationship on here for y that makes our whole life so much easier, and that is it's a vertical angle to 72 degrees. Well, if they are vertical angles, that means that y is equal to 72 degrees. Done. Now let's do x. We know some different things about x. X is adjacent to y, and it's adjacent to 72. He doesn't actually have a vertical angle buddy, really, so that doesn't help us at all. But if he is adjacent to y, or to 72, then we can start thinking about if he's a linear pair. In fact, x is a linear pair with both of them. So if we have a linear pair, we have y plus x equals 180. And then I have to plug in my 72 for my y. Or we have that 72 plus x is equal to 180 because he's a linear pair with both of them. So we can use either. I'm going to choose to go with this one. It's one less step. So I subtract 72 on both sides, and we get that x is equal to 108 degrees. Either way, I would have gotten the same answer, right? So hopefully you're feeling pretty comfortable with these. Hopefully you're thinking, yeah, this isn't too bad. Let me know if you have questions, and we do have skills practice on big ideas.